this session now. All right, so we are on lesson 4, day 1, automobile ownership and linear depreciation. You want to go ahead and put your name where it says your name, and the next question will be, what is the learning targets? It's right here, right? I can write, interpret, and graph a straight line depreciation equation. All right, you can just kind of select that and copy it, and then go on and paste it right in there. All right, now I know for sure that you've looked at the learning target for at least half a second in order to copy and paste it. All right, here's our first warm-up for today. Our warm-up for today, Jason. Jason does roofing over the summer. Jason charges each customer $500 plus $30 for every hour of labor to complete the roof plus materials. If the roof took him 30 hours to complete, how much will Jason charge for just his labor? Go ahead and think about that. If you're done with that one, once you get done with that one, you can work on the next one. Let me just give you a minute to kind of think it through. Okay, let me just talk about this then. So if the roof took him 30 hours to complete, how much will Jason charge just for his labor? Okay, well, we see that he charges $500, $500 to start. That's the fee he charges just to come out, just to drive out to a house to do the job. He's going to charge a flat fee of $500 just to drive out. And then he's going to charge an additional fee of $30 for every hour of labor, right? For $30 for every hour of labor. So we have, 30 times 30 here, right? 30 hours at $30 per hour. How to figure that one out? Well, as Mr. K already said in the chat, it's 500. 30 times 30 is 900. So 500 plus 900 is going to be equal to $1,400 just for labor. That's what Jason is charging just for labor, $1,400. The next question is going to be fairly similar to the last one, except that it says if the roof took him 30 hours to complete and the materials cost him $2,000, how much will Jason charge the customer? This should be pretty easy. Let me just give you like 30 seconds on this one. Oop. Because that one's so straightforward. Okay, for those of you who like to do things the hard way, and I'm kind of that way, you do like, here's the 500 to come out, here's the 30 times 30 for labor, and then plus $2,000 for materials, right? And then we can see that's going to be like $2,400 when you do the math. Some of you, though, probably like to do the things the easy way. Wait, no, $3,400, right? $3,400. Some of you like to do things the easy way, and you would just look at the 1,400 and just add the 2,000 on top of that, right? That's actually how I caught my arithmetic error right there, because when I looked at it the easy way, I'm like, wait a minute, I've missed 1,000 there. I've missed 1,000. So Jason is going to charge this customer $3,400 total for the roof, and of course, 2,000 of that Jason doesn't actually get to keep. That's actually what Jason spent on roofing materials. But the 1,400, that might be the more important number to Jason. That's the money he actually made that day or that week completing this roof, right? Actually took him 30 hours to complete. So that's how much he got paid that week, $1,400. It's not so bad. That's not so bad. Okay. And actually, if you can charge $3,400 to re-roof someone's house, that's really cheap. Yeah, you could get a lot of customers at that price. A lot of times a roofing company will charge easily 10 grand or 8 grand to re-roof a house. So if you're charging 3,400, you're making some pretty decent money. And yeah, something to think about. All right, what is the value of your car? What is the value of your car? Most cars will not be worth the purchase prices as they get older. Most cars depreciate. That is, they lose value over time. Some collectible cars increase in value over time or appreciate. The simplest form of depreciation is straight line depreciation. When a car loses the same amount of value each year, the scatter plot that models this depreciation appears linear. By determining the equation of this linear model, you can find the value of the car at any time in its lifespan. There are many factors contributing to the depreciation of an automobile. The condition of the car, the mileage, and the make of the car are only a few of those factors. The straight line depreciation equation is a mathematical model that can be used as a starting point in examining auto depreciation. In a previous chapter, we used, well, in a previous thing, hopefully, let's think, did we use this? No. So we're going to be using intercepts of linear equations when graphing expense and demand functions. Okay, so I'll show you how to do that with a linear intercept and a horizontal intercept. I'll show you how to do that. And we're going to use these intercepts to create the equation and find the slope. All right, so the slope of a line is a numerical value for the inclination or declination of that line. It is expressed as a ratio in the change in the vertical variable over the change in the horizontal variable from one point on the line to the next. If that just sounded like gobbledygook to you, that's okay. We'll get it straightened out. Just that's kind of the idea. The idea is that slope is the change in y divided by the change in the x. All right. Traditionally, the horizontal axis is called the x-axis, and the vertical axis is called the y-axis. Using those variable names, the slope of a line would be represented by the following ratio, right? The change in y divided by the change in x. That's the formula we're going to use to plot slope. So let's see. If we had two coordinate points, right? If we have a coordinate point where it's x1, that's for coordinate point 1, x1, comma, y1, and another coordinate point, x2, comma, y2. These twos aren't exponents or being multiplied or anything. These are just like names. That's the first coordinate point. That's the second coordinate point. Then we can kind of create an equation that will calculate the slope, right? The slope can be modeled mathematically by the following ratio. All right, the independent variable in the car's depreciation equation is time in years, right? The independent variable is usually time. Usually you want time to be the x-axis, all right? The independent variable. The dependent variable, the thing that's changing over time, is the car's value. By identifying the intercepts and slope of a straight line depreciation model, you will be able to determine the equation that represents the depreciation. So here we have these two coordinates, right? To calculate the slope, we'll take y2, and we'll subtract y1, right? y2 minus y1, that's the change in the y values. Then I'll look at the change in the x values, x2 minus x1, x2 minus x1, right? So I take the change in the y values, the change in the x values, and I take that divided by the other. The change in the y divided by the change in the x becomes my slope. So here is our situation. Suppose you purchase a car for $27,000. According to your online research, this make and model of car loses all of its marketable value after 12 years. That is, it depreciates to a value of $0 12 years after the purchase date. If this car depreciates in a straight line form, what are the intercepts of the depreciation equation? So we're going to let x represent years, right? Time in years. The minimum x value is going to be 0. All right, so it's basically when we're saying that when the time is 0, when x is 0, right? That's when this equation starts. That's when it's maximum car value. This is when the car is, this little coordinate point here is going to be when the car is brand new. When time is 0, when the equation starts, maximum car value will be $27,000, right? We're purchasing a car at $27,000. We have another coordinate point. We know the maximum lifespan is 12 years. At 12 years of time, we know the car value turns to 0, right? We're saying it loses all of its marketable value. So now with these two coordinate points, right? The first one, when the car is first sold at its maximum car value. The second point is going to be the maximum lifespan, when the car is worth 0. We can use these 2 points to create a slope. Actually, right now we're going to just identify the intercepts. Actually, that's what we're doing right now. So that's what the idea here is. We can create these two with a word problem like this. We can create 2 coordinate points, right? That's all right. We're going to get to slope in the next example. All right. So let's actually apply this. Let's see how you do. Suppose you purchase a car for $32,500. According to your online research, this make and model of car loses all of its marketable value in 15 years. That is, it depreciates to a value of $0 in 15 years after the purchase date. If this car depreciates in a straight line form, what are the intercepts of the depreciation equation? You're just giving me 2 coordinate points. 2 coordinate points. Go ahead. Give this some thought. How will you write the coordinate points? Use the example above to kind of help you out. If anybody wants to put it in the chat, that'd be lovely. That would help me know that you know what's going on here. All right. Now I think you know, this can be sometimes a head scratcher for students. I think the hard part actually for a lot of students is this part here, the intercepts part. So let me kind of like, I'm going to reproduce what happened over here. All right, my first coordinate point is going to be where x is 0, right? Where time is 0. Where time is 0 is where time begins, all right, for a given thing. So that x is 0 means this is where the thing starts. When I buy the car, when this thing starts, the car's worth is $32,500. So that's my first coordinate point. It's really just a matter of thinking, okay, where does this thing start and where does it end? And you got to put the zeros in the right place. All right. The second coordinate point, remember, time is going to be the x value. So I need to put 15 first. So this car loses all its market value in 15 years. So 15 comes first, comma, and then what's my y value? My y value is the money. And how much is this worth after 15 years? Well, it loses all of its marketable value. Therefore, 15 comma 0, right? It's worth $0 after 15 years. That gives me my 2 coordinate points, just like that. Now I'm going to switch it up, make it a little bit harder. All right. A car sells for $D and totally depreciates after T years. If this car straight line depreciates, what are the intercepts of the straight line depreciation equation? For some reason, you guys as students find this to be more difficult. I try to get you to practice doing things like this. This is expressing it algebraically. It's not hard once you get the hang of it. And please don't just wait for us to do this. You're going to learn a lot more by at home, just trying to scratch your head and figuring it out. Even if you don't come up with much, just trying to think really hard and making that brain hurt can sometimes be, you know, what you need to develop those neural pathways to learn this stuff. Math is not a spectator sport. Math is a skill sport. It's skill-based. You need to practice skills in order to get good. And I'm encouraging you to get good. G-U-D. Okay. A car sells for $D. So I know it sells at $D. So I know that when this function begins, time is 0, comma, capital D. That's how much it sells for. That's my first coordinate point, right? When time is 0, when this thing starts, comma, how much does it sell for when this thing starts? $D, they told me. I don't know what the value of D is, but you know, whatever it is. All right, and then I know that it totally depreciates after T years. All right, I want time to be first. So in this case, I'm going to put T first here because that's how many years after this thing totally depreciates. And totally depreciates means it has no marketable value left over, which means it has a value of 0, which means I can just put 0 right in as my second coordinate point. All right, so that's kind of how this is done. I think once you can do it algebraically, it's easier to do it numerically. But for some reason, students who can do it numerically just fine, they trip up when it comes to algebraically, even though to me it's almost easier to do algebraically. Yeah. Okay. Example 2. Now we're going to jump into slope. All right. Mr. Crane-Buell and I are just excited about slope, right? That's what math teachers, we love this stuff. Determine the slope of the straight line depreciation equation for the situation in example 1. Now we're going to find that slope. So 2 points, determine a line. So you can define any line by having, if you have 2 points, if you know any 2 points on a graph, you can determine the slope of that line, okay? And its y-intercept. Its whole equation is contained in just 2 points. Sometimes you got to think about that in terms of the logic of geometry. 2 points can define a line. Let the coordinates of the y-intercept be the first point, all right? That is x1 minus y1 equals 0, 27,000. So what they're saying here is, I wish I had a graph picture of this real fast. I guess I'll use my calculator to try to have us envision this. All right, I'm going to clear my lists. You don't have to do this on the calculator. Normally, I encourage you to do everything I'm doing to practice. This is actually just a visual. I want us to visualize this. We said that when this function starts at time 0, the value was $27,000, right? The value was $27,000 at time 0. Then we had, let's see, we said at when t was it 12 for this car? Yeah, 12 years, slowly depreciates. After 12 years, its value is 0. So we've done a little bit of math on this. We go stat, right? I already put the data in my list. I'm going to go to calculate. I'm going to do a linrag real fast. Negative 2,250 and 27,000. Okay, so negative 2,250 times x plus 27,000. And we're just going to take a quick look at what this looks like. So you can picture this graph in your head of what's going on here. I'm going to stat zoom. Oh, no, I want a graph. I want to zoom stat. There we go. That's what this graph looks like, okay? This point up here is where time is 0, right? Where the x value is 0 is right where it hits the y-intercept. That's where x is 0, right? This would be like 1, 2, 3, or something like that, whatever the number scale is here. It's going to be up to 12, apparently. And then this is where it hits the y-intercept, where x is 0, y is $27,000. And then the line that connects these 2 points, right, the straight line between these 2 points, this is where after 12 years, the value is 0, right? So now the dot is on the x-axis down here, because now the value up and down is 0 after 12 years. So you kind of see how that works. I wanted to show you how this graph looks before we talk about how to calculate the slope. And of course, the slope here is going to be negative, and I know that because I can see the line is going down. Almost always your slope will be negative in this unit, since we're talking about depreciation. All right, let's talk about the slope then. So we took the y values, right? We took the y values, 0, right? The y2 is 0. Y1 is 27,000, so 0 minus 27,000 is negative 27,000. And then we took 12 minus 0. 12 minus 0 is just 12. And we put this in our calculator. Negative 27,000 divided by 12 is negative 2,250. So the slope of the depreciation line is negative 2,250. That's how to calculate slope. All right. Now you determine the slope of the straight line depreciation equation for a car purchased for $32,500, which loses all of its marketable value in 15 years. That is, the depreciation depreciates to a value of $0 in 15 years after the purchase date. Round to the nearest hundredths and be sure to include whether your slope is positive or negative. Go for it. Yeah, that should do it, Mr. Cranbuell. So you're trying to think. Maybe you want to go back and maybe copy and paste your coordinate points. Maybe that helps you visualize this one. All right. Those are our coordinate points that we already determined. Cat decided she wanted to be let back out. And I'll say it doesn't matter which y value you use first, or which coordinate point you use first as the y1 or the y2, as long as you stick with that one as your first option, right? So there's two ways to do this one. You could do, so I'm going to take my y values first. I usually read from left to right on these equations. That's how I like to do it. That way I always remember what I did. 32,500 minus 0, right? I took this y value here, and I subtracted this y value from it. Divided by, now I got to take the x values. This x value here, I started with 32,500, so I've got to start with this 0 here. I can't skip around any way I choose. And then this 0 there, and then that 15 there. So 0 minus 15. You could have done it. You could have flipped it just as easily. You could have said, all right, I'm going to use 0 instead as my first y value, and then I'm going to subtract 32,500. That's perfectly legit, as long as you do that on the other side and start with 0 when you do the other end and subtract. Oh, no, wait. I started with this one. I started with, what did I do? I started with 0. I subtract 32,000. So now I got to start with 15 and subtract 0. So I got to start with 15 and subtract 0. All right. As long as either way, I'm going to run the math here and get my math machine. All right, math machine, you can do this. I'm going to start 0. I'm going to use the first, the equation I can see right there. 32,500 minus 0, close parentheses, divide, open parentheses, 0 minus 15, close parentheses. All right, negative 2,166.66666. All right, so in this case, I am going to have to do, let's see, put an equal sign. I was rounded there as hundredths. Negative 2,100, was it 66? Yes. Negative 2,166, and I have to round it to 67th cents. 60, I'm rounding nearest hundredths. Here's how I do that. The hundredth, the 6 here is in the hundredths place. I have to look at the thousandths place in order to figure out whether to round it up or keep it the same. The 6 is 5 or greater, which means the 6 rounds up to a 7. So my final answer, negative 2,000, negative $166.67. All right. It's important to put that negative in there. Slope. It's very important to be able to put a positive or a negative slope. All right. Just take a deep breath for yourself. Maybe just stretch. We're about to do something, express something algebraically. So let's get ready. All right. We're about to write the slope formula algebraically. All right. Get ready for this one. Write the slope of the straight line depreciation equation that models the situation in which a car is purchased for D dollars and totally depreciates after T years. All right, I'm not gonna like, yeah, you know what? I will give you some time to think about this. I was like, maybe I shouldn't, but no, I'll give you like 30 seconds. Think about this, see if you can do it. Tell you what, if you can do it, I'm impressed. Someone wants to impress me. Put their answer here in the chat. I'll be like, wow. Nice. For me, I'd have to write the coordinates again if it was me, in order to keep things straight. I'd have to be like, okay, wait a minute. 0 is when this thing starts. That's when time is 0 is when this thing starts, and it was purchased for D dollars. And then the other coordinate point is after T amount of years, it depreciates to a value of 0. Okay, now I could do it. I honestly, I probably couldn't. I would struggle doing this without writing out the coordinate points first, because until I see the coordinate points, I get confused. I get letters all shuffled up in my head. All right, no one's trying to impress me, I don't think, right here. So let me just talk this out. All right, I need to take the change in my y value. So D minus 0. I'm going to read from left to right. Start with this first set of coordinates and then move on to the second. So D minus 0, close parentheses, divided by, it's really not that hard, 0 divided by T. All right, open parentheses, 0. I'm sorry, not divide, minus T. I'm taking the difference, the change, sorry. D minus 0 divided by 0 minus T. All right, and you do need the parentheses. It's very important in this case to use these parentheses because you have a division symbol in the middle. without the parentheses, then the first thing that's going to happen is 0 divided by 0. And your calculator is not going to like anything divided by 0. Calculator was like, I failed to compute. Warning, warning, self-destruct imminent, right? Your calculator does not like dividing by 0. All right. D minus 0 divided by 0 minus t. That's what it's all about, folks. That's what it's all about. All right. Example 3. Example 3. Write the straight line depreciation equation for the situation discussed in the 2 examples above, and then draw the graph of this equation. All right. So the general form of equation. This is the stuff you guys love. I know you love it because we keep talking about this from 9th grade on. We never shut up about y equals m times x plus b, right? You've heard it a billion times. Where m, hopefully you remember this, m is the slope. M is the slope, that's what we just calculated, of a line. And then b represents the y-intercept, right? So the m determines how steep this line is, right? And then the b determines where the line touches the y-axis, all right? The b determines where the line touches the y-axis. So in this case, what we're working with, we have the slope is negative 2,250. All right, here's how you interpret slope. Interpret slope as for every increase in x, y does something, right? Something happens to the output, the y. In this case, for every increase in x, our value depreciates by $2,250. In other words, for every, and this is in years, right? This time we're using it here is years. For every year that increases, the value of the car loses $2,250. So that's the way you kind of interpret the slope here. The y-intercept is just going to be where the function starts. So you'll say when the function starts, when x is 0, y is 27,000. That's how you interpret slope. That's how you interpret y-intercept when it says interpret. Therefore, the straight line depreciation equation is y equals negative 2,250 times x times how many years we're talking about plus $27,000. All right. So if we already know the y-intercept because we have the coordinate points of where this thing begins, it makes it really, really easy to determine the equation. To graph the equation on a graphing calculator, first determine the appropriate graphing window. You saw how I did that. I had already had the points in there, and I just did zoom stat, right? I did zoom, press the zoom button, and then I went down here. Choice number 9 is zoom stat. If I press enter there, it'll choose an appropriate window for me to see the 2 points. However, if you don't have the 2 points, if you just want to see the line, you'll need to go into window, and you'll need to make your window something like, all right, let's start my window at 0 or maybe -2, just to make it so I can see things a little bit easier. But 0 is kind of the natural way to start. My x doesn't have to go any further than 15, so I can make this to be 15. My y minimum, I need to think about like, where does the value here start? I want this to be 0, and I think I want my y max to be like say 30,000. And I'm making these decisions based on how can I get right. How can I see what I want to see and fit everything I want to fit in here. I chose 30,000 because it's a little bit over the 27,000, and I saw it here on the graph. I chose 15 because I saw it here on the graph, and it's a little bit bigger than the 12 or whatever this problem is working with. And so it allows me to see kind of the whole line. -2 helped me see where the line goes past the y-intercept. If I just started it at 0, that's fine. I won't be able to see past the y-intercept, right? So it's all about how you want to do things. You can make some choices about how you want to view this with the window. All right. So I just showed you how to use the window. One such pair, right? Okay, we talked about that. Okay, we're good. Right, okay, your turn. Your turn. Give this a shot. Don't just spectate. This is not a spectator sport. Write the straight line depreciation equation for a car purchased at $32,500, which loses all of its marketable value in 15 years. Round the slope to the nearest hundredth. Put your equation in y equals m times x plus b format. All right. Go ahead and give this a shot. You're going to want to try it now because you're going to be lost when we have, when it's independent practice time. Right now, this is the learning opportunity that you're presented with, right? Here, learn this. Do this thing. Try this out. Put this skill in your toolbox. How about this? Raise your hand in participants when you got this equation. Raise your hand in participants when you got this equation. I feel like we got spectators here. I want to see we got live people here. Give me some indication in participants, a green check mark, a raised hand, anything. Let me know you're over there. Give me a green check mark in participants if you're alive. I know I'm talking at you a lot.
I'm alive, but I'm dead.
All right. Well, at least you're there. At least you're there. Thank you, sir. Javier, Yomari, we doing all right? Yomari's letting me know she's good. Javier, let me know things are good. Give me a green check mark, something.
I'm waiting to
Thank you. Thank you, sir. Thank you, sir. All right. Javier, let me know he's good. Okay. So it looks like we're alive, but we're dead. All right, fair enough. All right. So let me start again. Like sometimes for me, I need to put the stupid coordinate points on there. I don't know why I need this for myself, but I do. I know I need this for myself. I need to see the coordinate points or I'm just going to be confused. I'm going to get something confused and mixed up. Okay. There's my coordinate points. Now I'm fine. Now I have my coordinate points. I'm thinking, okay, it's the change in y values over the change in x values. So I'm going to put y equals, and then m is going to be my change in y value. So I'm going to say 32,500 minus 0. I could do that. I could do minus 0, but I know what that's going to be. I know subtracting 0 doesn't change anything. So I'm going to leave it just like that. And then I know that my next step would be 0 minus 15. I'm not going to put that in my equation. I'm just going to put in negative 15. I know that 0 minus 15 is negative 15. I can do that bit of math in my head. That's fine. The next bit of math, I'm not going to do in my head. I'm going to let the math machine handle this. Okay, and I made what mistake did I make when I put this in my calculator? Anyone want to help me out? What did I miss?
the negative.
Yeah, I dropped the negative. I wrote it down here, negative 15, but I dropped it when it's on my calculator. Now I know that I can just put the negative in later, which is why I was lazy about putting that in there, but that's a classic blunder right there, dropping that negative. All right, so I'm gonna get rid of what I have here and just substitute it with negative 2,166.67. Remember, that's the one we had a second ago. So I'm going to keep that negative 2,166.67 cents, right? That's the m. That's the slope, right? We just recalculated the slope essentially right there times the x. And this is really the easy part. B is going to be this right here. Why? Because remember, that first coordinate point is where the line hits the x-axis. Where the line hits the y-axis, where x is 0, right? So then our y-intercept is always going to be that number when x is 0. The y-intercept is the coordinate point when x is 0. Unfortunately, when we start these, we've got it. So right there it is. There's the equation for the line. I could even clean this up maybe. I don't need these parentheses per se. I could make that a little cleaner, but that's the basic idea. Y equals negative $2,166.67 times x plus 32,500. I might ask you sometimes to interpret the slope in context. You would say, to interpret the slope in context, for every increase in X, or for each additional year, I'd probably say, for each additional year, that's what X is, it's time measured in years. For each additional year, the value of the car will go down $2,166.67. And if I told you, asked you to interpret the y-intercept, you would say, when the time is 0, or when this function starts at where X is 0, the y value is just 32,500, right? If X is 0, then this just all disappears. If X is 0, the slope just disappears, doesn't even matter. And then that means y equals 32,500. All right. Second try. This is a slightly different problem. I want you to give this one a shot. We only have 5 minutes left. Maybe we'll wrap it up. Maybe we'll wrap it up right here. This is your exit ticket. I want you in the chat to give me an equation for this problem right here. All right. I'm putting this in the chat. You can leave 5 minutes early if you give me this linear equation here. I feel like it's a Monday and our brains are not quite in gear today. I'm feeling like you really need to try one in order to grok the concept here. Grok complete understanding. Well, fortunately, Mr. K, you only direct messages it to me, so that's fine. All right, in the chat, you're going to hit me up. In the chat, you're going to hit me up with this new problem. Write and graph the straight line depreciation equation for a car that was purchased for $22,000 and totally depreciates after 11 years. This is your ticket out the door, or you just wait out the clock, I suppose. Yeah, we'll finish on this. I think lately I've been trying to bite off a lot. So I don't want to pressure us on time. So we got we have example 4, example 5 left to get done. So I think we'll finish this up on Tuesday. No sense in crushing it. But do give me that equation for this one right here. Let me start you out. At least. This is the only part. I'm not actually going to give you the answer for this one. I'm not going to tell you, but I will give you the coordinate points to start with, right? When time is 0, that's when this function starts. I want to say that a lot. When time is 0, that's when the function starts. That way, when you hear that, when you think about it, you'll hear those words in your head. I'll be haunting your brain. I'll be living in your brain rent-free. When time is 0, X is 0, that's when the function starts. I know that I bought the car for $22,000. All right, I know that after 11 years, X is time. X is no longer 0, X is now 11. After 11 years, X is time. I know the value of the car, it totally depreciates. So I know the value of the car is 0. That's all I'm going to do on this one. I want you to give me the equation. Give me that equation. Wish me a happy Monday.
Yes, Desmond.
Don't forget to click submit at the end. All right, don't leave class without clicking submit. The submit button at the end saves your work. The submit button at the end saves your work. You gotta click that submit button to save your work for tomorrow. I wish we were in class right now so I could harass Javier and have him give me this equation. It's going to be y equals a number times x plus another number. All right.
They're tired.
All right, you guys are, yeah. You guys are tired. All right, just wish me a happy Monday. You went to the clock, right? You faced the clock, and the clock is 1. You can wish us a happy Monday now. Get on out of here. I'll stop sharing. Bye. Oh, Mari's already out. All right. Oh, I can stop.